Good day, sir. So today I'm going to share my presentation about the basic concepts of crystal structure. So there are seven lattice systems. The first one is the cubic system, known as the isometric system. All three axes are of equal length and intersect at right angles based on a square inner structure. So the picture below is the example of cubic system, and the second one is the trigonal system. Two axes are of equal length and are in the same plane. The main axis is either longer or shorter, and all three intersect at right angles. The third one is the hexagonal system. Three out of four axes are in one plane of the same length and intersect each other at angles of 60 degrees. The fourth one is trigonal system. Axes and angles in this system are similar to the hexagonal system, and the two systems are often combined as hexagonal. The fifth one is orthorhombic system. Three axes, all of different lengths, are at right angles to each other, based on a rhombic diamond-shaped inner structure. And the sixth is monoclinic system. There are three axes, each of different lengths. Two are at right angles to each other, and the third is inclined, based on a parallelogram inner structure. And the last one is the triclinic system. All three axes are of different lengths and inclined toward each other, based on a triclinic inner structure, meaning three inclined angles. So these seven crystal systems are a system for categorizing crystals based on their atomic lattice or structure. The atomic lattice is a three-dimensional network of atoms that are arranged in a symmetrical pattern. So the next is the periodic array of atoms. So this is my example of the periodic array of atoms. Crystals are composed of a periodic array atoms. The structure of all crystals can be described in terms of a lattice, with a group of atoms attached to each lattice point called bases. So as you can see in this picture, so these are the groups of the atoms that attach to each lattice points. So where the atom attached in the lattice point, it is called a basis. So the next one is the solid. A crystalline solid. More than 90% of naturally occurring and artificially prepared solids are crystalline. Minerals, sand, clay, limestone, metals, carbon, diamond, and graphite salts all have crystalline structures. A crystal is a regular, repeating arrangement of atoms or molecules. The majority of solids, including all metals, adopt a crystalline arrangement because the amount of stabilization achieved by anchoring interactions between neighboring particles is at its greatest when the particles adopt regular rather than random arrangements. So the example of these solids, crystalline solid, are the minerals, sand, clay, limestones, metals, carbon. So the next one is the types. What are the types of crystals? So the types of crystal are covalent crystals, ionic crystals, metallic crystals, and molecular crystals. So what is covalent crystals? So covalent crystals are crystals whose atoms are connected with covalent bonds. Covalent bonds exist where the atoms share electrons. These bonds are extremely strong and very hard to break. The second one is the ionic crystals, are crystals whose atoms are held together with ionic bonds or charged bond. With these ionic bonds, one atom is negatively charged and is attracted to other atoms in the crystal that are positively charged. The third one is the metallic crystals, are crystals made of metal elements. These crystals sparkle with a lustrous sheen. We think of metals having. And the last one is the molecular crystals. Molecular crystals are crystals formed from weak bonds called hydrogen bonds. These have to do with how tiny charged particles on atoms, called electrons, are arranged between different hydrogen atoms. So, what is molecular solids? A molecular solid is a solid composed of molecules held together by the van der Waals forces. Because these dipole forces are weaker than covalent or ionic bond, molecular solids are soft and relatively low melting temperatures. So there are three characteristics of molecular solids. These are the soft, often volatile, have low melting temperatures, and electrical insulators. So that's all. Thank you.